I'm in the process of repairing and restoring a PDP11-34 vintage computer. I'm currently dealing with some issues with the main CPU boards, but I'm taking a bit of a break from that and dealing with some other issues, one of which is the cooling fans. There are two of these large cooling fans on the machine, and in fact I think one of these fans has been replaced at some point. The two fans are different, and one of them, when I turned on the machine initially, didn't rotate at all. In fact, one of the viewers commented that he thought only one fan was running, which was true. And it wasn't burnt out or anything. These are just standard motors in these fans. They're not brushless or anything. These are horrendously noisy, huge airflow, and they do spin very fast, and it does take quite a toll on them, as well as making a lot of noise. But I freed up the fan that was stuck, and it just appeared to be just stuck. It was very tight, and I just rotated it back and forth, and eventually it freed up, and then it spun up for a while, but was horrendously noisy. It's mechanically noisy as well as the wind noise. This one's also very noisy mechanically. You probably can't hear it, but it's making a kind of knocking noise as it spins round. It's quite free to spin, but it's quite noisy mechanically. The other one was a bit worse than this, and it turned out that it wasn't just seized up over time. What had happened is the centre spindle is held in, or was held in, with three small kind of steel rivets, and they'd come loose, and there's not a lot of free play or free space between the core that spins in here and the stator, and this was kind of moving about. You can see where it's worn, and ultimately it looks like one of the rivets had snapped, and it was still in there. It kind of dropped inside because there was a sticker on the outside here. And so I took this out. I was going to change the bearings in these anyway, so I took this out, and because it had been moving about, and when this was running I could see the PCBs kind of vibrating side to side. It was causing so much vibration, and it turned out what had happened is the fan was hitting the case, and it had kind of loosened itself from the centre boss, and started breaking up this inner part of where the rotor sits into the fan moulding. So I've reattached that. I made a tool for the lathe. This is kind of flared over. There's a kind of a thin aluminium flange. So I made a tapered tool, put this in the lathe, span the assembly round at about 1 RPM, and then just use the tailstock to push the tapered tool I'd made to spread this out. So I coated it with epoxy first, and that was about a week ago, and this is now well and truly one piece again. And I can now replace the bearings. I had to replace the bearings on this one anyway. What I found when I was taking it apart was one of the bearings had actually broken up, and the other one is well on the way out as well. It doesn't really turn very well, but one of them had started to disintegrate, so it's perhaps as well that I was replacing them. So as ever, they are standard bearings. In this case these are 626 size bearings, and these are ZZ type. If you're not familiar with bearings, the ZZ just means it's got a metal dust shield, and you get different types, but ZZ just means it's got a metal dust shield on each side. But they are standard size bearings, so I can refit the two bearings. There's one on the front, of course, one at the back. Okay, so I'll get those refitted, but before I do that I need to make up some new rivets, rivet this back on, and then I can reassemble it. So what I thought I'd do, I'll do that off camera, but what I thought I'd do for this video is just replace the bearings in this fan. Also notice that the fans are completely different size blades, and different number of blades, so I think one of them at least has been replaced at some point, possibly because of the same fault. Okay, I'll get this taken apart. So to get these apart, if you've never done this, all you do is you pop this front cover off. So in this case it's metal, on the other one it's plastic. This should pop out. I haven't tried it yet, but it should just pop straight out, so I'll get that taken out. Okay, that's the metal guard out of the way, and we should be able to withdraw the actual fan blade assembly. So that's a small clip. And then the fan just pulls off. Make sure it doesn't lose the spacer washer. And all I have to do now, I'll check that this is tight as well, so it actually seems tight. All I have to do now is drive out the bearings, put in the new ones, and then it's good to go. As I say, it's a lot simpler than the other one. The other one I just now need to reattach the shaft, and then we'll be at this point where I can refit the bearings. But you can see this one has much smaller bearings, so I'll measure these. I've probably got some knocking about somewhere, and get them replaced. I've got the first bearing removed. There's a sleeve and preload spring that sits between them, keeps them pressed apart, and then it's just now a case of taking out the bottom one. So just put in a small drift, give it a tap, and it should come straight out. And that's the second one removed. And all I've got to do now is press in the replacements. So I'll dig out some new bearings. Reassembly is just the reverse of taking it apart, and then this will be ready to go back into the machine. Okay, well that's the bearings replaced. I just need to refit the dust cap. Before I do that, I want to run it up and test it. And these normally connect directly to some 120 volt taps on the transformer. So in the UK here, 240 volt mains, but the fans are driven through a 120 volt tap, or 220 volt taps on the transformer. But they run flat out all the time, make a horrendous noise, and they actually blow far more air through than we need in a fairly cool environment. And especially because this machine's not going to be fitted into a rack, it doesn't need anything like the same amount of airflow. Now I was going to fit some smaller 12 volt fans, but I'd really like to keep it as original as I can. So I'm making a modification. I'm not changing the machine, just adding something to it that can be removed at any time, and that is, I've made up this. Bought a cheap speed controller off eBay and just wired it up so that these two connections go to the original connections coming out of the transformer, and these ends of course connect to the fan. So I'll get this connected up to 120 volts and we'll see if it actually works. Okay, I've got this coupled together. It's just taped down to make sure that these wires don't move around, and we'll try and power it up. It's set to 125 volts input, and if we turn the speed up we should be able to control the speed of the fan. So I'll see if it actually works. So that's the speed it normally runs at, a lot quieter than it was. The mechanical noise has stopped. I can now slow it down, make it much quieter. That's probably adequate for what it needs, and it's probably 10 times quieter. It's probably not coming across on the microphone so much because it's obviously going to resonate through the worktop, but turned right up, there is a huge airflow coming out of this thing, and it's really far more than it needs, especially with two of them. But turning it down will make a huge difference. So all I need to do is put the control, I'll probably have it inside the machine, I doubt I'll make it externally accessible, and I'll just put it on a bracket, turn it to whatever speed seems most suitable, use the thermal camera to keep an eye on things for a while, and once it's running at an adequate speed I'll close it up, and that should make the entire machine far more pleasant to use. And of course, if ever I want to take this out, it just unplugs and I plug the fans back into the transformer. So that's the fan issue almost sorted out. I just got to finish off the broken fan, remake the rivets, reassemble it, and the fans can then be bolted back into the machine.